Y'all didn't have homework? Yeah, you did. Didn't you? Yeah. Yeah, because y'all were fussing about 20 problems. You remember. I think most of you did most of it in class. There you go. I don't remember. 9. There you go. Yeah. Yes. If you sing it. Nobody. 17. Somebody sing with me. Hot July moon. All right, so 17. Yay, yes, do it. My favorite song. Okay. It's also my favorite number because. Okay, so I'm going to take a GCF out first. What can I take out of everything? 5, not just 5. 5A. When I take out 5A, what's left? 4B, 7C. I can't do anything else. I'm done. That's it. Yeah, that's it. That's all you can do. They're nice when they're like that. What else? 20? Somebody say 20? I can't. Okay, so I have this problem. I used to could hear really good. I can't hear as well as I could. But I can usually hear really good. I can never tell the direction it comes from. So, like you said that, and I look back here because I don't know. Isn't that weird? Like, I can hear it, but I don't know the direction. Y'all are looking at me like, does Henry do that? Do we have that in common? Are we hearing problem twins? No, I'm talking about, like, direction. You know what I'm saying? Like, you might say something to me, and I might look on this side. And, like, I heard it, but I don't know where it came from. Made for an interesting life, though. Okay. 4x cubed plus 8x squared minus 49x minus 98. If you see 4 terms, what should you automatically think? Slash. 1 year I made all my kids do that every time they slash. And so you, huh? Yeah, they did it. We all did it together. And then they did it, yeah. I'm telling you, most of the time my students are fun with me. Yeah. Y'all are getting there. You're getting there. I know. I know. I know. I know. That's awful. Then that's no fun. That's boring. Then that's why y'all hate school. It's boring. Okay, what can I take out of the first two? 4x2 or 4x squared. What's left? X plus 2. Middle sign stays. What can I take out of the last two? 49. Right. I couldn't hear what y'all said. Okay. X plus 2. Remember when the middle sign's minus, it changes that last sign, yes? Okay. So what's my common factor now? X plus 2. Sorry. But wait. I'm not done, right? Why am I not done? There's a difference of 2 perfect squares right here. So I'm going to factor just that piece again. So I've still got the x plus 2 out front. How does that factor? 2x minus 7 plus 7. How do I know I'm done? I look at every single parenthesis and go, I can't do anything else with it. Done. Yes? What else? I would love to do the bonus one. Did anybody get the bonus? You didn't have to do it. You didn't have to do it. This one's fun. We'll actually do some like this soon. But all right, GCF, does it have one? 3x. If I take that out, tell me what's left. To the 4th minus 3 goes in 20 what? 9. Any ideas what I could do now? Let's see if it'll slash. Let's try this. Multiply the first and the last together. Is there anything you can think of that multiplies to 100x to the fourth but adds to negative 29x squared? What you got, Angela? Yes. Negative 25. But what's the variable on here? X squared. Because if it adds, they've got to be like terms. So they've got to add to this, but multiply to the fourth. So this would be 3x times x to the fourth minus 25x squared minus 4x squared plus 100. Slash it. Ready? Okay. 3x. What can I take out of there? X squared. What's left? Uh-oh, I see something. Middle sign stays. What can I take out of those two? 4. What's left? So I got 3x, x squared minus what? It's a lot. We'll get to that next unit, actually. But yeah, it's a lot. Now what do you see? Difference of squares. Twice difference of squares. This is why it was a bonus. So x minus 5, x plus 5, x minus 2, x plus 5. Did anybody get that? No, you didn't. Did y'all get it for real? Yay, y'all. Pat on the back. Y'all are a unit ahead. All right, anything else? Going once? Twice? You got a question, Henry? You sure? So the quiz always picks up from the last quiz, so it won't include the last quiz, but anything since the last quiz up to what we did. So the next one will probably be factor and then factor and solve, which is what we're doing today with the special pattern. Good question, though. Anything else? I can. Number 4, 5v squared. I have some people that say I'm changing that to an x because I don't like anything but x. If that's you, that's okay. GCF, does it have one? 5. What's left? Look at y'all go. What multiplies? By the way, I think I'll go ahead and show you this little shortcut now, since we've already spent a day on doing the long way. If this leading coefficient is a 1, some of you may have figured this out already. If that leading coefficient is a 1, there's really no need to slash it, because whatever multiplies to 8 but adds to -6, those are what's going to go in the parentheses. And let me show you what I'm talking about. What multiplies to 8v squared but adds to -6v? -4, -2, yes? So whenever I set this up, v squared minus 4v minus 2v plus 8. GCF of the first two, v, leaves me v minus 4, minus GCF of the last two, 2 leaves me v minus 4. So I have 5 times v minus 4 times v minus 2. I didn't actually have to slash this one because the -4 and the -2 were what goes in the parentheses. This, I don't show you this initially because it only works when there's a 1 leading coefficient, like there's not a number there, and you'll start doing that for everything and then it doesn't work. So I always show you the long way first and then come back to that. But if you want to shortcut it, you could look at this one and just factor from there. Really no work to it. What else? What? What? Sold. Anybody know that song? Sold to the lady in the second row. She's an 8, she's a 9, she's a 10. I'm glad you know. Even if you didn't sing it with me. All right, ready, Freddies? Let's switch gears. today's going to feel like a repeat of what we've already done, and that's because it kind of is. Y'all want me to give you a second to get set up and ready? Y'all look at me just like, this is what y'all look like. And I'll say something, there's not even an emotion. It's just, what in the world, y'all? Oh my goodness. Yeah. I taught Kenzie 3 years. I know. Then I might as well just retire. I've loved being here with my kids. Some people don't like it. Like Miss Lopez came from the middle school and her kids go to Lugoff because she wasn't sure about teaching with her kids. Like she didn't know she wanted. I know. Would y'all like your parents to? See, some people are like no, and some are like yeah. Now I'm not saying they enjoy it. I enjoy it. I can I give them a much harder time than everybody else though. Really? Didn't like it? Your mom had who? Her mom? Oh. Your mom what'd you say? Your mom what? It's hard to be a teacher. It's hard to be a teacher. All right. Saw everything. All right. Tell me what you know. I don't know what X or Y is, but tell me what you know. Why? Anything. Only way to get 0 is if one or both of them is 0. Do we all agree? That is called the 0 product property. And you guys already know that, so you're great. 0 product property. It says if 2 or more things are multiplied together, then one or more of those things has to be 0. So X must be 0, or Y must be 0, or both of them are 0. Any one of those would make my equation true. That is the 0 product property. Everybody okay on that? Okay. So maybe you have something like, all right, so that's thing 1. We're going to kind of do 2 separate things, then we're going to pull everything together. When you are solving something like this, what do? Subtract the 3, right? I move the 3, I get X all by itself. What if there's more than just that? What if it's 2X minus 7 equals 23? Okay, so how do you know that you add 7 before you take care of the 2? Okay, you're exactly wrong. What I mean by that is PEMDAS simplifies, but if I want to solve, you do isolate the variable, but how do I know the order to isolate the variable in? So instead of PEMDAS, it's the opposite. That's why I said you're exactly wrong. Okay, it's SADMAP. We solve in the order of SADMAP. I say map because nobody says map. But anyway, did y'all not have teachers that taught you that there's an order in which you solve? You just do like there's 2 x's of the regular numbers. Okay, so as we get more complicated, you'll need to understand the order and why we do what we do, right? Because the longer the equation gets, then the crazier it gets. So what I'm doing is remembering that parentheses and exponents are last, and I'm looking for anything that is added or subtracted to the x first. Well, what's added or subtracted? That's why I'm adding that first. Okay, so I'm going backwards order of operations here. So I add 7. Now I'm done with addition subtraction. Now what? Divide by 2, right? So x equals 15. Okay? All right. But what if? What if I said solve that? Okay, so Jason says subtract 6. If I subtract 6, here's where I am. What would I do now? Divide by 5. So if I divide by 5, I have to do the entire side. So now I have 1/5 x squared plus x equals negative 6 over 5. Somebody said what? Divide by what? Divide by 5x? Like instead of dividing by 5, divide by 5x. Okay, so now I've got 5, this is a 5x on the bottom. This x is gone, this is just 1, and I've got a 5x on the bottom here. No? Square root, I heard a square root. Square root the whole thing? Right at the beginning. I'm setting you up for failure here because I'm add or subtract before the square root. So I moved that 6, I've got x squared plus 5x equals negative 6, and I do a square root. Do you know what the square root of this is? Or anybody? I don't either. But what if? I stumped y'all. Okay. What if I could? So I've got, here's my original equation, right? The point that I'm getting to is your normal methods are not working. Right? Obviously, we cannot figure this out by normal solving equation methods. So what if I could get this to where it looked something like one thing times one thing equals 0? Then I would know that either thing 1 or thing 2 was 0. It's like you have to factor it. Who would have thought? Because isn't that what factoring does? Something times something else, right? That's exactly what we're going to do. So when we have equations that we need to solve that are quadratics, can I move from here? No, y'all are like, you should have told me because I got all this in my notes. No, wrong. No, y'all aren't going to say anything. Y'all just All right, solving quadratics. The first step we're going to do, because we're wanting to employ this zero product property, right? In order to use the zero product property, our first step has to be to make the equation, equal 0. Some way, somehow, just put everybody on the same side. Make sure it equals 0. Okay? Then we're going to factor it the way we've been doing. And then we're going to take each piece, which each piece is a factor, so each parenthesis. Set each factor equal to 0 and solve. Now, I'm going to try to bring this full circle for you just a second. How many answers will I likely get when I solve a quadratic? 2. If I am making the equation equal 0, what really am I finding? You're finding the x, I'm finding the intercepts. I'm finding the x-intercepts. So does it make sense that I would have 2 solutions? Will I always have 2 solutions? No, because remember, some of those parabolas are above or below, right? Or whatever, or the vertex sits on the axis, okay? So just keep that in mind, because everybody says, I don't understand why we get 2 solutions. Well, that's why, because really what we're looking for are the intercepts, okay? All right, so let's just get ready. Okay. Um, I didn't run some. I'm gonna start these going around because I think I'll do a few examples off of here. Oh, nice catch. Terrible toss on my part. This is number 18 on the sheet that's coming to you. If you want it in your notes, put it in your notes. You might want it with your notes so you have an example to go along with your notes, but just so you know what we're doing. All right, so my first step, and I did run the page that had the little steps for you right there on top. I think I probably should have gone from the ends in. When you get them to the back, when that back row gets them, pass them to the outside rows because they don't have it. Out. Just don't have it right now. Are y'all whiting out the part that I messed up on? I mean that we didn't. Okay. All right. First step. Make it. All of y'all have all this white out and stuff. It is. I think because she's going up and down instead of across, maybe. And I don't know. We didn't have that fancy stuff when I used whiteout. We had liquid. Okay, make it equal 0. What? Now, I will give you a hint. Because we learned the general way to factor, we grouped. There's no right or wrong side to move it to, okay? But it will make it easier on you if you keep your leading coefficient. What's leading coefficient mean? The one with the x squared, the a. If you keep that positive, if you move everything to the side that makes it positive. So looking at it, it's positive on the left side. Oh, look at that color. Oh, I'm on. So it's already positive on the left side, so I think I'll move everything to the left side. Does that make sense? Okay, so when I move, and if I do this in too few steps, tell me. I'm going to move the x, so I move it by subtracting. And all in one step, I'm going to go ahead and add the 9 too, because I like to do as few steps as possible. If you want to subtract the 11, get the answer, and then add the 9, that's fine. The goal is that there's nothing left over here, right? Okay, so I've got 4x squared. What is negative 11x minus x? Negative 12x. No? Y'all okay? Plus 9. Equals 0. I picked a special one. Look at here. Did anybody pick that up? You did, Henry? You did, Blaine? Good. Okay, tell me why it's special. The squares. It's a perfect square trinomial, right? The first thing that clues you in are the ends are perfect squares. Now, if you didn't recognize that, it's okay. You just multiplied the first and the last together, go through and factor. But if you did, this is a perfect square. What times itself twice gives you 4x squared? 2x. This is a perfect square. 3. Square, square. Say it with me. Multiply and double. Thank you, Henry. You were the only one doing your hands with me. I appreciate that. So 2 times 3 is 6. Doubled is 12. So it is a what? Who can't move their hands? What is? I would probably feel really bad. I feel bad easily. Can you tell? It would make me feel bad. I might even cry. Like Henry. We could cry together. We'll just step out in the hallway and boo-hoo. All right, so when I factor this, yes, it's 2x minus 3 squared. Terrible first example because of what it does, but that's okay. So this is the same thing we know as 2x minus 3, 2x minus 3. So I still have two things multiplied together, yes? That's what I was getting to here. So I set each piece equal to 0. Thing 1, thing 2. But I'm going to get the same thing, right? Because they're the same fact. What does that mean graphically? The vertex is on the x-axis. Perfect. And that vertex happens to be, come on, add 3. Because we're going in what order to solve? SAD map. That's exactly right. Divided by 2. This one has only one solution, and it is 3 over 2. And the reason is, if I came over here, I would get the same solution. So it's the same. No need to write it twice. But that's the solution. Yes, no, maybe so. See how it's still what we did yesterday? There's just an extra step there. I'll do another one. Bless you, whoever that was. Let's do number 2 together. Make it equal 0. It already does. Step 1's done for you. Okay, now what? Factor. Okay, what's my first step of factoring? Because this one looks a little different. GCF, what's the GCF? 4x, right? 4x times what? X minus 2. Can I factor anything else? No, and that's okay. Remember, to use zero product property, I need something times something else. Do I have that? Isn't this 4x times x minus 2? Does it matter that it's not in parentheses? It just matters that it's multiplied. So it's this times this. Yes? X equals no matter what else this parabola is doing, it is crossing at 0 and 2, and he's going up, right? Up and skinny. So I don't know where this vertex falls, but it's going to do something like that. I could figure out vertex, but I don't want to. Yes? What do you think? Yes, that was a nice chat. What if I end up in a scenario like this? So multiplied, right? Remember, 1 or more has to be 0. Is 3 ever going to be 0? No, 3 is not ever going to be 0, so that can't be one of my zeros. So when it's like that, you just ignore it unless it has a variable in the front. If it was 3x times x plus 2 equals 0, then I would say 3x equals 0. Do you see the difference? Variable would give me the 0, just a constant number would not. You can also think about it like I could just divide both sides of the equation by 3. This would cancel and leave me with this equals 3, whatever's easier for you to understand. If y'all don't have any questions, I'm going to set you loose. But if you do, I'll be happy to answer them. What you got, Olivia? Sure. Sure. So 3 and 4, we'll do 4. It looks a little bit harder. In order equals 0, yes. Do I have a GCF? No. How does it factor? It's difference of squares, right? So that means it's 3x minus 5, 3x plus 5. Yes? So what are my solutions? Yes. Add 5 divided by 3, so I got 5 over 3. Subtract 5, and I got negative 5 over 3. Yes, no, maybe so.